biology major, and today I'll be presenting analysis of spatial learning and memory in Neuropilin-2 knockout mice. Knockout mice is mutated mice to work in the lab. So let's start. So when you guys first got here, did anybody get lost in any way? Have one person get lost. Okay. Did you finally remember? Did you see your surroundings and you remember that, oh, maybe this is the right place to be? You know, maybe I'm in the right place. Or maybe you used...
yes, I did. And I still got lost.
But the main thing that played a major role was Neuropilin-2. Neuropilin-2 consists of three extracellular domains: A1, A2, B1, B2, and C. And then it contains a transmembrane and a short cytoplasmic domain. And at the bottom, it consists of a motif, PDZ, which it's used. It helps connect the neuropilin with other cells. So here we have neuropilin. Neuropilin is a receptor, multifunctional, which helps exons, the guidance of exons, which means that pretty much when the nervous system sends a signal, it's going to tell the body what to do. But in order to do that, the Neuropilin-2 has to attach to the plexin. And once it attaches to the plexin, then the semaphorin 3F, which is the signal, will be able to attach with neuropilin. Once that happens, the plexin will send that signal, which is semaphorin 3F, the sema, and once it sends that signal, what's going to happen is going to help the nervous system, especially the hippocampus, well, let's say the hippocampus is going to activate the axon growth cone collapse, which is a process of being able to put together all these signals and put it in the right place. So now here we have the hippocampus. Neuropilin-2 has a high level in the hippocampus, and it's also part of the limbic system. The limbic system is, you have the temporal, and these are the system that you're able to do movements. And also has to do with memory. So damage to the hippocampus can cause spatial memory damage or a decrease in spatial memory. And also, in a mouse model, what will happen is that the hippocampus will affect the learning. So let's see. The purpose was when I started out the experiment, I wanted to decide, okay, earlier studies of neuropilin showed that in a post-natal growth of the nervous system, it was really high in the neuropilin level. Even the 7th day, the 21st day, and the 45th day, it's up to 1 to 45 days. And after the 45 days, you're expecting neuropilin to go away, but no, it was still in there. And that's when I began the purpose of my experiment, which is to study the effect of neuropilin and being able to see if neuropilin will create impairments of memory. And so I had to start somewhere. So I started out with knockout mice, and I compared it to the control, which is a wild type. So I proposed that the absence of Neuropilin-2 will create impairments and will affect brain function. It will cause a delay. So in order to start the experiment, I had to start somewhere. So I started out with the water maze. Well, the water maze in 1980s, it was a really good experiment to test spatial memory. So it involves putting in the mice in there to swim, and then we mix paint with the water, and we had to kind of blind the mice so he wasn't able to see his the
Surrounding.
the surrounding, but also you're not supposed to see what's inside the water, which was kind of like a template on top of the water, like a platform. So we started out with 4 mice. We thought that the first brown mice, we had 3 black and 1 brown. The brown was a male. So we said, okay, the brown is going to be the Neuropilin knockout mice, the one that does not have it. Here's an example. I'm sure you guys the maze water maze says I have to click it. It's like a video. No. Okay. Well, it's a video, and what actually is gonna happen is I'll put the mice on top of the platform. I'll let them stay there for 5 seconds, and then I will switch them and put them on the first quadrant, then the second, and then the third, and then the fourth. I will test for about a minute to see if he's able to find it. The first 4 days are going to be training days, and then day 5 to day 9 are going to be the actual days that is going to be included in the data. So here's the data. For quadrant 1, you can clearly see the mice, number 1 was really fast. And then second, third, and fourth had a little bit of trouble. Again, mice 1 was the one that we believe was the Neuropilin knockout. Quadrant 2. Now they begin to have an increase in quadrant 2. Quadrant 3, you see that they're able to, 1 and 2 are able to find pretty quick compared to 3 and 4. And again, 3 and 4 is still having trouble, but being able to find it. And so we did a genotype, genetic analysis of it, to see if which one was the knockout mice. Actually, so here we have the first one and the second one are going to be the knockout mice. And so, comparing to the data,
also additionally, microfluidic mice is going to be really, really small. So
well,
small.
Sorry about that. The third and fourth are going to be the knockout mice. My bad. So, comparing to the data, mice 1 and 2 appear to learn pretty quick. Well, 3 and 4 was the slowest one. So, based on the genetic analysis, I concluded that in the table, I concluded that neuropilin does affect the mice's learning in spatial memory. But because of our results, even though the N is very small and it's an experiment that we need a little bit more time, so the results is preliminary. Acknowledgements. I want to thank Teal Sam, Miss Howard. She helped out with the genotyping, and Colican Lab for holding the mice, and Francis Noir, he's not here today, and here are my references, and that's it.